Welcome back. In this video, we'll talk about data visualization in Base R. In a future video, we'll talk about the ggplot2 package. First, I want to look at Notebook 3.1 from the GitHub to point out a couple of things. The first is that I have a couple of really good links here, one for graphical parameters in Base R, and the other one is for color names. One more thing I want to point out in this notebook is that in this section of code, I was getting some really annoying warning messages that I didn't want to show up in my HTML or PDF rendering. And so you can set this warning equals false parameter here to prevent that. Notebook 3.1 in the GitHub gives examples of plotting a single variable. Notebook 3.2 gives examples of plotting two variables. We'll look at Notebook 3.1 first. I'm going to share this notebook with the PDF rendering instead of the RMD file in RStudio so you can see the graphs better. If you're plotting a single column, it might be quantitative or it might be qualitative. This notebook loads the Titanic data and converts some of the columns to factors, giving us a few qualitative columns we can plot. First, let's look at plotting quantitative data. This par function here can be used to set up a 1x2 grid in order to display the following two graphs. The problem is that we'll override our graphical parameters, so what we do before that is we save our default parameters into variable opar, and then after the graphs are plotted, we restore them. We can plot a quantitative vector with a histogram or a scatter plot. In the case of the scatter plot, the x dimension will just be row indices. For the histogram, I used a slate gray color. The link at the top of this notebook leads you to a page of colors and names. I also put in labels for main and the x-axis. In the scatter plot, I changed the dot style to be an open dot and changed its size, and the background color will either be snow or slate gray, depending on if the person survived the Titanic or not. Since there are so many data points, it's really hard to see a difference here. I've switched to the HTML view because the page breaks in the PDF were in inconvenient locations. The histogram gives us a nice visual impression of the distribution of age. We can see quite a few children and a few elderly people. The bulk of the people in the middle tend towards the younger side, maybe the early 20s. The density plot can give us similar information as to the histogram, but it smooths out the data. First we calculate the density and then we plot it with a polygon. Package SM lets us create a density plot with overlays. This is the code chunk where I asked it to suppress warnings. Some warnings were suppressed, but not all of them. First, we subset the data frame to just have two columns, passenger class and survived. And then we got rid of any rows with NAs. Three colors were chosen to show age by passenger class. So we can see that passenger classes 2 and 3 tended to be younger people, and passenger class 1 was most likely families. We see a broader curve here because families have people of all ages. This code created a box plot for age. Box plots are usually vertical. If we want them horizontal, we put in this parameter. What the box in the box plot shows you is the middle two quartiles with the median shown by this bold line. The edges, sometimes called the whiskers, show the range. Dots outside of the whiskers are suspected outliers. The box plot gave us similar information as the histogram, but also shows us the outliers. Now let's look at how we can plot a vector that is qualitative. We can create a bar plot by first creating counts using the built-in table function. So we see here that passenger class 3 had many more people than the other classes. The same information can be in a bar plot here by just saying horizontal equals true. Finally, this is the code to create a pie chart. Notebook 3.2 shows how to plot two variables using the same data in preprocessing as Notebook 3.1. If we have two variables, then we have these four possible cases here. Both x and y are qualitative, x is qualitative, y is quantitative, x is quantitative, y is qualitative, or both are quantitative. First, we look at the case when both are qualitative. We're using library VCD for visualizing categorical data, and it prints a mosaic chart. We can see of people that did not survive, they're much more likely to be in passenger class 3. Although it looks like the people who survived from passenger class 3 and passenger class 1 seem fairly equal, remember that there were many more people in passenger class 3 than passenger class 1. When x is qualitative, a factor, and y is quantitative, box plots are good choices. Our first plot, we see that we have survived on the x-axis and age, our quantitative variable, on the y-axis, and we see our box plots. The var width equals true parameter will make the boxes wider or narrow according to the distribution of the class. The 0 class of not survived is wider than the survived class. Notice we can have a couple of different syntaxes here to get the same plot. This next code plots passenger class on the x-axis and age on the y-axis. So again, we're using var width equal true, and the notch equals true puts a notch here at the median. We see that passenger class 3 tends to be younger. When x is quantitative and y is qualitative, a conditional density plot can be used. This plot shows how survival changes over the various ages. The cdplot function is used for a conditional density plot, and we specify our x and y. There's a very unusual dip here, so people in this age range are likely to not survive, but if they get a little bit older, I guess people had sympathy for them and they survived. If you end up with a plot like this, then you know you've done something wrong. So what's wrong here is that the y-axis is the factor, which is binary. So that's why we see all of the points at the two locations. If both x and y are quantitative, that calls for a scatter plot. This plot has age on the x-axis and ticket price or fare on the y-axis. There weren't really any other quantitative variables to choose from, so I went with this one. The PCH specifies what the dot will look like, and here we specified size and color. It seems that a few people paid $500, which would have been a lot of money in 1912, and a lot of people paid $0. That's probably because one person in the family paid and others paid nothing. I spent a lot of time on data exploration and visualization because that's the first step in all of our machine learning homework assignments. In the next video, we look at the first algorithm, linear regression.